Now let us solve few sums based on finding out the sum of the given series. Now here we have to evaluate 1 into 2 plus 2 into 3 plus 3 into 4 and so on up to n terms. Now here in this type of questions, the first step is to recognize any general term tr in terms of r. So that means we have to somehow develop the pattern and write tr in terms of r. So if you look the first term, it starts with 1, second term starts with 2, third starts with 3. So therefore rth term will definitely start with r. Alright, and in each of the product, the second term is nothing but 1 added to the first term. Alright, so 1 plus 1 is 2, 2 plus 1 is 3 and so on. So therefore if the first term of tr is r, that must get multiplied with r plus 1. So therefore tr is nothing but r square plus r, isn't it? So this is the general term in terms of r. Now whatever sum that we have to find, that is nothing but ultimately sum of all such tr terms, and here r varies from 1 to n because here we are given n terms in general, right? So therefore that is further equal to summation of, now tr is nothing but r square plus r, which we just found out, and we have to sum from 1 to n, right? Now as we know, we can break up this particular summation into two different summations, that is summation of r square plus summation of r. Right, now here it's assumed that r varies from 1 to n. Now we know the formula for summing up the squares of first n natural numbers. So that is given by n into n plus 1 into 2n plus 1 whole divided by 6, and sum of first n natural numbers, which is nothing but summation of r, that is given by n into n plus 1 whole upon 2. So therefore we can now merge both of these terms, and we can take n into n plus 1 common from numerator, and let's take 6 common from denominator, so that in the bracket we are left with 2n plus 1 from first term, and the second term will have the factor of 3. Alright, so that gives us n into n plus 1 whole upon 6 into 2n plus 4. Now we can take the factor of 2 from the last bracket and cancel that with the denominator 6. So therefore finally we will get n into n plus 1, and from the second bracket, once we take the factor of 2 common, we will be left with n plus 2 and whole divided by 3. So therefore the required sum is obtained in terms of n. So if they specify how many terms, then we will plug in that value of n, but this is the answer in general, right? Now let's go ahead and see another variety of question here. Now here it is given as 1 cube upon 1 plus 1 cube plus 2 cube upon 1 plus 3 and so on, and this also we have to evaluate for n terms. Now if you observe this, we have to once again develop the formula or the expression for rth term in general. Now if you observe the numerator, you can see that it is a sum of cubes of first r natural numbers. So we can write this in general as 1 cube plus 2 cube plus 3 cube and so on up to r cube, because whatever is the term number, we have to go up to cube of that. Now divided by, now let's look at the denominators, that is first denominator is 1, then we have 1 plus 3, then we have 1 plus 3 plus 5. Alright, so if you observe that, that is nothing but sum of odd numbers, because we are having all the odd numbers there. But how many odd numbers? So it is the same number of odd numbers as whatever is the term number. So if we have the first term, we are taking only one odd number, that is the first odd number. If we have second term, then we are taking two odd numbers, right? So that means here we can write as 1 plus 3 plus 5 in general up to the denominator will contain the last term as the rth odd number, isn't it? And the rth odd number is given by 2r minus 1, provided r starts with 1, and which is the case in our case. That is, r will always start with 1 and go up to n in this particular example. Now simplifying this, if you observe the numerator, it is a sum of cubes of first r natural numbers, for which we have the formula as r square plus r plus 1 square whole divided by 4, right? Divided by, now if you look at the denominator, it is nothing but a simple arithmetic progression with the starting term as 1 and the common difference as 2. So therefore we use the formula for sum of n terms of the arithmetic progression. Now here the terms are r in total, so therefore we will have r by 2 into bracket 2 into first term, which is 1, plus number of terms minus 1, so that is r minus 1, and multiplied with the common difference, so which is nothing but 2. Alright, so simplifying that further, we have, now we can cancel the 2 with 4 and that leaves 2. We can also cancel the r with the r square in the numerator. So finally we have r into r plus 1 the whole square whole divided by, we have 2 here. Now in the bracket, after simplifying, we get 2 plus 2r minus 2. So you see here 2 will get cancelled and we are left with r into r plus 1 the whole square, and we have 2 into 2r, which gives us 4r. So you see that r also gets cancelled. So therefore finally we have tr as r plus 1 the whole square upon 4. Right? Now we may think that we have to expand this r plus 1 the whole square and then sum all the individual terms using the sigma notation, but instead of that we'll now use a different trick here. That is, see what happens, we have to take the sum of all the tr terms, right, from 1 to n, right? So that further equals summation of r plus 1 the whole square upon 4, and r varies from 1 to n, correct? So that is equal to, we can take 1 by 4 outside the summation because it's a constant. So here we have summation of r plus 1 the whole square, and as r varies from 1 to n, correct? So that means if we literally list down all the terms, which is nothing but 1 upon 4, now when we put r equal to 1 in the expression, we will get 1 plus 1 the whole square, it is nothing but 2 square, plus when we put r equal to 2, we will get 3 square, and so on up to, at the end we will get n plus 1 the whole square, correct? So this is what we have to find out. Okay. Now let us find that. So here we will rewrite the expression. So s is nothing but 1 upon 4 into bracket 2 square plus 3 square plus 4 square, and so on up to n plus 1 the whole square. Now won't it be nice if we had 1 square also in the beginning, so that we could have directly used the formula to add the squares of first n plus 1 numbers. So to do that, we will add and subtract the missing number, that is 1 square was missing, so we will add it and then later on subtract it. So 1 square plus 2 square plus 3 square, it goes up to n plus 1 the whole square, right? And we have to also subtract 1 square because we had added it on our own. So that gives us 1 upon 4 into bracket. Now sum of this particular curly bracket is nothing but sum of squares of first n plus 1 natural number. So we'll use the required result for that, so which is n plus 1 into n plus 2, and further we have 2 into n plus 1 plus 1, right, whole divided by 6, and finally minus 1. Okay, so that gives us 1 upon 4 into bracket, we have n plus 1 into n plus 2, and we have 2n plus 3 in the third bracket upon 6 minus 1. So on simplification and taking the terms common, we finally get the sum as equal to n into 2n square plus 9n plus 13 whole divided by 24, which is the LCM, right? So this is how we find out the required sum.